This is the Math 2 Unit 11 review worksheet. This is our second quadratics unit. So we start with number 1. What is the value of c that makes each perfect square trinomial? So this fits into completing the square. And we're not going to solve here. We're just finding the values that make it work. And what we're going to do is we're going to take half b and square it for all of these problems. So b values here. So 16 over 2 is 8. 8 squared is 64. So c would be 64 to make a perfect square trinomial. What that means, though, is if I had x squared plus 16x plus 64, the numbers that multiply to 64 that add to 16 are x plus 8 and x plus 8, so we'd say x plus 8 squared, which gives us that perfect square trinomial. For number 2, we have negative 8. So we take half of negative 8 and square it. That's negative 4 squared, so it would be 16. It would work the same way to factor. Number 3, half of 6 squared gives you 3 squared, or 9. Number 14 is negative 14. Take half of that is negative 7. That squared is 49. For number 5, we take half of 5 and square it. Now this is the first one that's not even, so that's still going to stay at 5 over 2. I'm not going to simplify the fraction, but I'm going to square the top and the bottom, and that gives me 25 over 4. And for number 6, negative 24 over 2 gives us negative 12 squared, which is 144. Down here at number 7 through 10, we're going to solve by completing the square. So the same process we did, but now we're going to finish the process. So I got a squared plus 12a. I'm going to take the 32, move it over, and now I'm going to put a value in that does what we did above and completes the square. So half of 12 squared is going to be 6 squared, or 36. So I'm going to add this to both sides. Now the right side becomes 4, because it's negative 32 and 36. The left side, it's going to become a plus 6 squared, because the number that multiplies to 36 and adds to 12 is 6, and that factors. It should work like this. It should simplify to be a single term twice whenever we do this, because that's the purpose of completing the square. So now we take the square root of both sides, and I get a plus 6 equals plus or minus the square root of 4, or a plus 6 equals plus or minus 2. So a plus 6 equals 2 and a plus 6 equals negative 2 gives us answers of negative 4 and negative 8. For number 8, we're going to take 44, put it on the other side. We're going to take half of negative 14 and square it. That's negative 7 times itself gives us 49. The left side is going to become x minus 7 squared, because negative 7 and negative 7 multiply to be 49 and add to be negative 14. The right side is just 5. We now take the square root of both sides and we get plus or minus the square root of 5. We add 7 over 7 plus or minus the square root of 5. And since it's an irrational term, it's going to stay as a radical. We'll just write it as this. But do realize it does mean it could be 7 plus root 5 and 7 minus root 5. For number 9, the first thing I'm going to do is divide everything by 2. So I got n squared minus 6n plus 12 equals 0. And really I divided 0 by 2 also. So now let's take the 12 and move it to the other side. We take half of negative 6, which is negative 3. That squared is 9. So the left-hand side becomes n minus 3 squared equals negative 3. Square root of both sides, we get plus or minus the square root of negative 3. Now, the square root of negative 3 is going to become I root 3. So we have n minus 3 equals I plus or minus I root 3. Add the 3 over, 3 plus or minus I root 3. This is a complex solution because we had the imaginary with the radical, and we'll just write it as this. Next one, I'm going to divide everything by 4 before I start. P squared minus 2p minus 15 equals 0. We then get p squared minus 2p, add the 15 over. Half of negative 2 is negative 1. We square that, that's a positive 1 to both sides. So the left-hand side becomes p minus 1 squared equals a 16. The square root of both sides, plus or minus the square root of 16 on the right, leaves us with p minus 1 equals plus or minus 4. So I'm going to write p minus 1 equals 4, and p minus 1 equals negative 4. On the left one, I add 1 over, we get p equals 5. And for the right one, add a 1 over, and I get negative 3. Now to number 11. Now on 11 I changed it here. We had a typo. We're going to make that 0 instead of 15. It just makes it a little bit easier to solve and to fix our problems with picking the terms. So we're going to substitute into quadratic formula based off our values. Now remember here a is 1, b is negative 9, and c is 21. So quadratic formula is negative b, so we put negative 9 there, plus or minus the square root of b squared, negative 9 goes there, minus 4ac. All of that's over to a. So that shows we know how to substitute in. Now we need to simplify it. So I'm going to clean up this first. That's going to become a 9. The denominator, I said 2a, well actually 2, 1, because a is 1. That's a 2 there. So we got plus or minus square root. Negative 9 squared is 81. And then minus 4ac, this is 4, 1, and 21, which is 84. So that's minus 84. So simplifying further, we get 9 plus or minus the square root of, that's negative 3 over 2. We need to change that to a complex solution, plus or minus I root 3 over 2. So we could write it as that. Or we could split it and make it 9 over 2 plus or minus I root 3 over 2 if we wanted to separate it. It just depends on the format the answer needs to be in. For number 12a, we're going to do the same thing. B is negative 20, A is 1, and C is 91. So we're going to do negative 20, negative 20, 4, 1, 91. And on the bottom it's 2 and 1. So we clean things up. This becomes a 20. Denominator is a 2. Plus or minus. 20 squared is 400. 4 times 91 is 364. And that's going to be a minus. So inside the radical, 400 minus 34, or 400 minus 364 is 36. So that's 20 plus or minus 6 over 2. I'm going to separate this to two solutions here. 20 plus 6 over 2 and 20 minus 6 over 2. Top one gives me 26 over 2, or 13. The bottom one gives me 14 over 2, which is 7. So my answers are 13 and 7. For number 13, we're going to solve by quadratic formula, similar to what we just did. So that's going to be x equals negative b plus or minus b squared minus 4ac. Filling in the appropriate values, all of that is over to a. Same process as before, we're going to clean things up. This is going to stay as a negative 10. Down here is a 4. Inside the radical, I'm going to square, so that's my 100. And then I look here, I got 4, 2, and negative 3. These actually got two negatives here because it's negative 4. Negative times a negative is a positive, so I'm going to make that a plus. Then 4 times 2 times 3 is 24. So we have negative 10 plus or minus the square root of 124 over 4. Now sometimes we want to reduce the 10 and 4 here. We can't do that unless we can reduce all three values. So we have to simplify the square root of 124. So 124 is 2 and 62. 62 is 2 and 31. So that's actually going to become negative 10 plus or minus 2 root 31 over 4. Now I can divide all of these numbers by 2, and we get negative 5 plus or minus the square root of 31 over 2 as our answer. For number 14, now it's a little bit different, but I need to move everything to the same side. So we got x squared minus 6x plus 14 equals 0. Now we can use quadratic formula. So that's going to be a minus a negative 6 plus or minus negative 6 squared minus 4 times 1 times 14. All of that is over 2 times 1. This becomes 6 out in front, 2 on the bottom. Inside my radical I got 36, and then this is going to be a negative because it's negative 4, positive 1, and positive 14. But 4 times 14 is 56. So we got 6 plus or minus the square root of negative 20 over 2. Now, negative 20 in the radical, 20 is 4 and 5, so I can take out a pair of 2's. I'm also going to take out an I, and this is going to become 6 plus or minus 2i root 5 over 2. Last thing we're going to do is divide all three of these numbers by 2, and I get 3 plus or minus I root 5. For our next part, we're going to solve each equation for x using any method. Simplified radical form and complex solutions need to be in terms of I. That's just kind of the standard way we write it. So, 15, first thing I'm going to do is going to move everything to the same side. Now be careful here that it becomes x squared minus 3x minus 1 equals 0, not x squared minus 1 minus 3x. We want to still be in that proper form, that proper order as we go. So I look at this, doesn't look like it's going to factor, so I'm going to use quadratic formula. So that's negative 3 plus or minus negative 3 squared minus 4 times 1 times negative 1. All of that over 2 times 1. So we got 3 plus or minus the square root of 9 plus 4 over 2. And then we're going to go 3 plus or minus the square root of 13 over 2. Doesn't simplify anymore, so that will be our solution. For number 16, I could use quadratic formula, but I'm going to try something different. I'm going to solve by square roots. So I'm going to add the 121 to the other side. I'm going to take the square root of both sides, so x equals plus or minus the square root of 121, which gives me plus or minus 11. So that means my answer is 11 and negative 11. Now, if you solved with a different method, but you still got the same answer, you did it correctly. It's just the method I happen to choose. For 17, let's move the negative 6 over, and I'm going to add that. So that's going to be a negative 33. Okay, quadratic formula is what we're going to go with. So that's going to be a negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 33. All of it over 2 times 1. So we got negative 8 plus or minus the square root of 64. I got two negatives here, so that's going to be a addition. So 4 times 33, I'm going to add 132 to 64. So 132 plus 64 gives me 196. That's over 2. 196 is 14 squared, so that's negative 8 plus or minus the square root of 14, or 14 over 2. So we got negative 8 plus 14 over 2, and negative 8 minus 14 over 2. Well, this becomes a 6 over 2, so 3. And that becomes a negative 22 over 2, so negative 11. So my answers are 3 and negative 11. Last one, 3a squared minus 15a. Could use quadratic formula here. A is 3, b is negative 15, c is 0. What I'm going to do is I'm going to factor, though, a 3a out. Leaves me with a minus 5. So then 3a equals 0, and a minus 5 equals 0. I get a equals 0 from the 3a equals 0, because you just divide by 3. And then add over, and I get a equals 5. There's my two solutions. All right, on to complex operations. So we're going to treat I almost as like a variable, like an x, until it becomes I squared or I to the third, and then we simplify it from there. So we start with this. I'm going to first distribute. I'm going to go 7 plus 3i plus 15 minus 27i. Now, I combine like terms. 7 plus 15 is 22. 3 minus 27 is going to be negative 24i. So my answer is 22 minus 24i. For number 20, I'm going to distribute first this negative 2. So that's negative 24 plus 6i. And then, oops, I forgot to distribute in the front. And that's going to give me 8 plus 32i. So 8 minus 24 leaves me with negative 16. 32 and 6 gives me 38. So my answer is negative 16 plus 38i. For number 21, we're now multiplying. I get 27i squared, but I squared is equal to negative 1. So that becomes 27 times negative 1, so my answer is negative 27. For the next one, I'm going to pair up and make I squared. That's kind of my strategy here. So these two, and bring this one down. So I got negative 20i squared, 14i squared, and 3i squared. Now we just said I squared is negative 1. So I could go in and get rid of all of the I squareds and change their sign. So that becomes 20, negative 14, and negative 3. We've gotten rid of all the i's. Now, make sure we multiply it back together. But 14 times 3 is 42. And 42 times 20 gives me 840. For number 23, I'm going to use the area model. Whenever I multiply binomials, I'm going to treat it the same way. 2 minus 3i and 6 plus 4i. I get 12 minus 18i, 8i, and minus 12i squared. So let's write these out. 12 minus 18i plus 8i minus 12i squared. Now these two are common, so I got negative 18 and positive 8, so that's going to become negative 10. Bring down the 12. I squared is negative 1, so that becomes positive 12. Last thing I do is I'm going to put these two together, and I get 24 minus 10i. For number 24, same thing. We're going to go 2 minus 3i and 5 minus i. Make sure you put the negative in front of the I so you don't miss it. We got 10 minus 15i minus 2i and 3i squared. So now we write them out. We got 10 minus 15i minus 2i plus 3i squared. These two, the i's, are going to become negative 17i. 3i squared becomes negative 3. So 10 minus 3 is 7 minus 17i. 25. Sometimes students want to take it and square the 7 and square the 2i. That is not what this says. We need to treat 25 like problems 23 and 24 and multiply with the area model. So that's 7 plus 2i and 7 plus 2i. So we got 49, 14i, 14i, and 4i squared. So let's write them out. Oops, 14. So 14 and 14 is 28. Bring down the 49. 4i squared is become negative 4. So 49 minus 4 is 45, and then 28i. 26, same process. We're going to go 7 plus 2i and 7 minus 2i. We got 49, 14i, negative 14i, and negative 4i squared. So when I write them out, it's very similar to the last problem, but 14i minus 14i is 0, so that's gone. 49 is still good, but negative 4i squared. I squared is still negative 1. Change it to a plus 4. So we're left with 49 plus 4, and that's 53. We don't need to write any term for I because there isn't a term for I, and that's our answer. So for number 27, we need to select the graph with the correct solutions. We are f of x and g of x. This one we can look at the graphs that we have and start to eliminate answers instead of worrying about all the little details within each graph. And what I mean by that is f f of x equals x squared. That's a parabola. That is a parabola that opens up. So with that, b is gone because it opens down. Next, I have negative x plus 2 is g of x. That is a line that has a y-intercept of 2 and a slope of negative 1. So that means when I look at it, it means it starts above the y-axis, or the x-axis, intercept of 2, and it should look like this. Well, that eliminates c, that eliminates a, so D is my answer. Now that shows, what the question's saying is right here are the solutions for the graph. That's when they equal each other. But what the question's really asking us is, can we just identify the equations? Can we identify the graphs that we have and then use process of elimination to get there? But then we go to 28 and 29. So now they've given us the equations and we're thinking about what makes the solutions. And the solutions are when the x values are the same, which come from when they intersect. So in 28, if I look at the parabola and the line, they do not intersect. They do not meet. So that means there are no solutions, there are no x values that they have in common. 30 though, they do intersect. They intersect here and here. So what are the x values when they cross? Well, this is on the y-axis, so 0 is one of them. And this looks like 5 is the other. So x equals 0 and 5 are the solutions. So when it's no solution, it looks like this. They don't intersect. When it's two solutions, they intersect at 2 points. You may also see one that has one solution, and that would look like that when it comes in and hits the parabola at 1 point, and that would also be an option. But the thing to be aware of there is you're looking for the x values. That would be the solutions. All right, moving on to graphing. We are now graphing in standard form. In standard form, we want to find the vertex by doing negative b over 2a. So the x value is negative 12, that's negative b, over 2 times 2. So this is now 12 over 4, or 3. We then take that, substitute it back in to find the y value of the vertex. So 3 squared is 9, times 2 is 18, minus 36 plus 10. 10 and 18 is 28. So 28 minus 36 is negative 8. So our vertex is 3, negative 8. So I'm just going to sketch that out, go over 3, go down, negative 8. It's about right here. Now if we think about it, the 2 tells us it opens up. So we kind of think it's going this way. Okay. Axis of symmetry, we need to find that. Well, axis of symmetry is the vertical line that cuts it in half. So that's when x equals 3. The x-intercepts. We'll get to the x-intercepts. That's going to require us to solve. But first, I can find the y-intercept really easily. The y-intercept is this line. This line is when x equals 0. If I go to this equation, and I make all the x's 0, which are those two, I'm left with just a 10. That is actually our y-intercept. So right here at 10 is the y-intercept. It's actually the point 0, 10. So the parabola goes through that point. Now, what helps us, we went over 3 units to get to that, because we were 3 away. If we go 3 the other way to the point 610, that gives us our other y-intercept. Now it's not directly asked in this problem, but it allows us to then get an idea of what the graph looks like. So 0, 10 is our y-intercept. The other thing I start to notice, before I solve this, my x-intercepts should be in between 0 and 3, because that's where it kind of hits, and then it's probably going to be bigger than 3 over here. Just things to keep in mind, because if you get like a weird negative answer and you're like off over here, that doesn't seem to fit the graph, and it all should fit together. So let's go find the x-intercepts. So I'm going to say when y is 0, I have 2x squared minus 12x plus 10. If it doesn't factor, we're going to have to use the quadratic formula. I don't really want to have to use that if I don't need to. So first, let's divide everything by 2, and I get x squared minus 6x plus 5. Is there two numbers that multiply to 5 that add to negative 6. And there is. That's going to be negative 5 and negative 1. So I can take those two values and say x minus 5 equals 0 and x minus 1 equals 0 to get x equals 5 and x equals 1 as my two x-intercepts, which we look, 1 and 5 fit into the graph, and those would be our solutions. All right, for the next one, graph the parabola in standard form again. So we're going to start with our vertex, and we're going to go negative b, or negative 6 over 2 times 3. That gives us negative 6 over 6, or negative 1. We then put that back into the equation to find the y value of our vertex. Negative 1 squared is positive 1, times 3 is 3, minus 6, minus 9. It looks like we're going to get negative 12. So negative 1, negative 12. So we say that's about right here. The axis of symmetry is when x equals negative 1. Let's also look. The y-intercept, like we just talked about, is at negative 9. So right here, at 0, negative 9 is the y-intercept. If we go on the other side of that, negative 1 is 1 unit over, so we go the other side, so that's negative 2, negative 9 would be our other point. We can sketch out the graph. So from this, I'm thinking my x-intercept should be a positive and probably a number smaller than negative 1 as I solve. So let's look. We got 0 equals 3x squared plus 6x minus 9. I'm going to divide everything by 3, and I get x squared plus 2x minus 3. So what can I multiply to get negative 3 that adds to positive 2? Well, if I had a negative 1 and a positive 3, that would work. So we're going to go 0 equals x minus 1, x plus 3. Then x minus 1 equals 0, x plus 3 equals 0. We get x equals 1. That seems to fit. And x equals negative 3. That also seems to fit. And those would be our two x-intercepts. We should write x equals for those. All right, for 32 and 33, we're given a quadratic function, and we need to write it in vertex form. So we can use completing the square for this. We can also use what we know about a graph and finding the vertex to do that. I'm going to show you the completing the square route and give you a hint for the other method. So first up, I'm going to say f of x equals, in parentheses, I'm going to say x squared minus 12x, and then put the 10 out to the side. Now, what value is going to complete the square? I take half of negative 12 and square it, so that's going to be 36. Now, normally, we then take the 36 and we add it to the other side, but I don't want to put it with the f of x. So I almost want to think of that like a zero sum. If I added 36 to one side and subtracted it from the same side, it would keep it balanced, because really I just added 0 total. So what this does is now this parenthesis factors to be x minus 6, quantity squared, and a minus 26. If we stop and look, that is actually in vertex form. We don't have to go any further. We don't have to solve. So this worked. Now, the other option is we can go a little bit indirectly. So f of x equals x squared minus 12x plus 10. I know vertex form looks like what I have here, a x minus h squared plus k. Now, give you a first hint. The a value here is the same as the a value here. So that's actually just going to be a 1. So what I have to find is h and k. H and k are the vertex. The way I find the vertex, I just did up here and do negative b over 2a, or negative 12 over 2 times 1, which gives me, it looks like a 6 over 2. That'd be 12 over 2, which is 6. I then put that back in and say f of 6 is 6 squared minus 12 times 6 plus 10, or 36 minus 72 plus 10. 46 minus 72, it looks like I'm going to get negative 26. So my vertex is 6, negative 26, which then I can put into vertex form, change this sign, it's negative 6, and that's negative 26, which works and matches to what I had also. So if you're good with completing this square, that is another application to get to vertex form, but you also have the option of saying, hey, if I'm in standard form and I want a vertex, I can find that and plug it back into vertex form. Just a different way to get to it. All right, so for 33, let's just do the first method. You can always do the vertex if you'd like. F of x equals, so I got 8x squared plus 16x, and I'm going to kick out the negative 22. But I want x squared not to have a coefficient, so let's take the 8 out of that. So I factor an 8 out of this parenthesis, and I'm left with x squared plus 2x minus 22. So half of this, half of 2 squared is 1. I add 1 here, so I want to subtract 1 here. But wait, this isn't really 1. This is 1 times 8. So I'm going to subtract 8 on the outside. From here, I put it together. We got 8, and then this factors to be x plus 1, quantity squared, minus 30. And there's our equation in vertex form. So for 34, we have an equation, we have k. We need to figure out what value we can put in to give us the difference between real solutions and no real solutions. So let's start with just saying, well, what if x minus 1 squared plus 2 equals 0? What if k was 2? If I did that and subtracted 2 over, I would then get x minus 1 squared equals negative 2. From here, and I'm not going to write this out, I then start to see I take a square root of both sides, and I end up with the square root of negative 2, which is going to lead me to an imaginary solution. And if it's an imaginary solution, it's not a real solution. So that happened with positive 2. I moved it over, it became a negative. That would actually happen with any positive number to start with. So if k is greater than 0, it would give us no real solutions. So 1, 2, 3, any of those. On the other side of that, well, let's think, what if it was a negative? So if I started with x minus 1 squared minus 2, I would get x minus 1 squared equals 2. I would take the square root of both sides, and I'd get like square root of 2, and that's fine. That's a real solution. It may not be a nice rational solution, but it is real. So that's going to happen if k is less than 0. So negative 1, negative 2, negative 3, any of those. Okay, let's take that approach to the next problem. So next problem, I'm just going to put a 2 there. So I got negative 2, x plus 4 squared minus 2 equals 0. I add 2 over, and then I'm going to divide by negative 2, and I get 2 over negative 2, which is negative 1. That negative, when I'm going to take the square root, is going to lead me to no real solutions. So this case, if k is less than 0, negative 1, negative 2, negative 3, any of those, which probably means if it's greater than 0, it would work. Well, let's take a look. Negative 2, x plus 4 squared, let's do 6. Just for the sake of picking a number, we get x plus 4 squared equals negative 6. I divide that by negative 2. I get a 3, which if I take the square root of both sides, I'm going to have the square root of a positive number, which works. So if k is greater than 0, it would work. 1, 2, 3, any of those values. For number 36, we have a firework is launched off a platform. It's 10 feet high. So if you think about it, it starts 10 feet up in the air. It reaches a maximum height, and it comes back down. And this function models that behavior. So how long does it take to reach the maximum height? Now our function, it's h and t. t is on our x-axis, which is time. H is our y-axis, which is height. So how long does it take to reach the maximum height? If we look at the vertex, the x value is the time, the y value is the height. So we want to find the x value in the vertex. So we take our function and we think, well, the x value in the vertex is negative b over 2a. So we go negative 160 over 2 times negative 16. We get negative 160 over negative 32, which comes out to be 5. Does that make sense? Well, at 5 seconds, yeah, it's a positive value. It seems realistic. So that's the time, 5 seconds. And then the maximum height would be the value when its x is 5 or t is 5. So we're going to put 5 in for t and solve. So 5 squared is 25 times a negative 16 gives us negative 400. 160 times 5 is 800. And then we add 10. 800 minus 400 plus 10 leaves us with 410 feet. For our last problem, we have Aaron Judge has a function for the home run he hit being 496 feet, is here. And then Bryce Harper's is 467 feet, which gives us this function. So we're just going to use these functions to answer the questions. So whose ball reached a greater vertical height? Now, since the function is time to height, we want the y value in the vertex, and that's for both of them. So we start with negative b over 2a gives you the x value. So for Judge, we're doing negative 160 over 2 times negative 16, which gives us 160 over 32, which is 5. We then put that back in to get the height, which is negative 16 times 5 squared plus 160 times 5 plus 4. So we have 5 squared is 25 times 16 is negative 400. 160 times 5 is 800. And plus 4, looks like we have 404 feet. Next problem, for Harper, we're going to do the same thing after we close the window. And we got negative b over 2a, so we get negative 128 over 2 times negative 16, negative 128 over negative 32, 128 over 32 gives us 4. We put that in negative 16, 4 squared plus 128 times 4 plus 4. So we got 4 squared 16 times 16, that's negative 256. 128 times 4 is 512. So we're going to do 512 minus 256 plus 4 gives us 260 feet. So greater vertical height is clearly Judge. Okay, next question. If a ball were to travel until it hit the ground, how long would Judge's ball be in the air? So now we want to figure out when it hits here. Now if we solve this, there's actually 2 x-intercepts. One is in the negative because the way the functions looks, there's a y-intercept. So go back here. We want to find the positive solution of that. So that's the x-intercepts, that's the solutions, that's the roots. We're going to use quadratic formula to allow us to do that, and we want the positive answer. So quadratic formula, it's going to give us negative b, so negative 160, plus or minus the square root of 160 squared minus 4 times a, which is negative 16, times c, which is 4. All of that is over 2 times negative 16. So we got negative 160, we got a negative 32. Inside we got 160 squared, which is 25,600, Then it's going to be a plus, because we got two negatives. 4 times 16 times 4, 256. So we've got negative 160 plus or minus the square root of, we add these together, 256 plus 25,600. That looks like it's going to be a perfect square. In my calculator, that comes out to not be a perfect square. All right, so let's start to approximate. So if I had the square root of 51,200, I want the positive. So let's just do this. Let's go to a decimal. That's about 226.3. So it's negative 160 plus or minus 226.3 over negative 32. If it's a negative divided by a negative, that gives me a positive. So I want these both to be negatives. Negative 160 minus 226.3 over negative 32. So we got 160 and 226.3 together. Negative 386.3 over negative 32. We got 12. So x is about 12.07. Let's come back over here. So that tells us at about 12 seconds until it hits the ground. All right, that's that one. Now let's do the same thing for Harper's. So quadratic formula again, we're going to go negative b plus or minus b squared minus 4ac. Now this is actually very similar, except the 128s instead of 160. So let's bring some numbers down. We got negative 32, negative 128. 128 squared is going to give us 16,384. This we already did. That's 256. Let's add that. So now we got negative 128 plus or minus the square root of 16,640 over negative 32. We then take the square root of the 16,000 number, and it's about 128. So negative 128 plus or minus, we'll call it 128, it's 128.99, let's just call it 129 over negative 32. As with before, we want to take the negative here, so we go negative 128 minus 129 over negative 32, gives us 257 over negative 32, so 257 divided by 32, and that's about 8.03, so we'll call that 8 seconds.